When asked to predict whether it will rain in a specific place in the next few hours, meteorologists get it wrong, a lot, which is super frustrating. Rain seems like it should be easy to track, and knowing if it's going to rain is a pretty important detail for all of us. But it turns out that rain, at least some of it, is really hard to forecast at small scales. Welcome to Minute Earth. There are two main ways that rain forms, and while we're really good at forecasting one kind, we're really bad at predicting the other. The first kind, which makes up about 40% of the rain we experience, is the long-lasting gray skies all day kind of rain. This comes from giant air masses called fronts, which move around the planet. When a cold one runs into a warm one, the warm one, which is less dense, gets lifted up. As it rises, it quickly cools off, which causes tons of water vapor in it to condense right where the two air masses meet and then fall as rain, or snow, or sleet. Since the fronts themselves are large and easy to track with radar systems, not only can meteorologists tell pretty much exactly where this type of rain will fall, they can also measure the size and temperature of the two air masses and use that to accurately predict how intense the rain will be and how long it will last. But the majority of rain we experience comes from a process called convection. This type of rain happens when heat from the ground warms up a small mass of air, which then rises and cools, causing the water vapor in it to condense and fall to the ground. That process of rising, cooling, and condensing is very similar to what happens with frontal rain. But because convective rain is triggered by heat from a small patch of ground, rather than the temperature difference between two large masses of air, it's much more complicated. It's hard to know how warm various parts of the ground will be at a particular time, whether that heat will be enough to lift a particular mass of air to a particular height, how much water vapor that particular mass of air holds, and how long that particular mass of air will stay over that particular patch of warm ground. As a result of all these variables, rain from convection can look like a light sun shower or a severe thunderstorm, and it can be over in minutes or last for hours. What's more, the masses of air involved in convective rain are often way smaller than the resolution of most meteorological monitoring systems. So not only are the mini storms hard for radars to detect, but even if the storms do get detected, meteorologists have no idea if it's raining in the whole area or only parts of it. And here's the extra frustrating thing about this hard to predict type of rain. Because it gets kicked off when the ground gets heated, it's way more likely to happen in the summer and in places with lots of heat-absorbing materials like cities. So when this type of rain does fall, it's often at a time and place where lots of people are gathering together outside. In other words, it's not all that uncommon for it to literally rain on your parade. More accurately predicting rainfall will help us with all sorts of stuff. Air travel, farming, water management, emergency planning, and more, especially as the weather gets more extreme. That's where this video's sponsor, DeepMind, comes in, an AI research lab working on some of the hardest problems in science. DeepMind's weather forecasting AI treats radar data like a movie, predicting the next few frames in the scene based on what's come before. Even though researchers are still working to get this technology ready for prime time, they've seen huge increases in the accuracy of short-term weather forecasts. If AI is going to benefit everyone, the researchers and engineers working on it must have diverse perspectives. So DeepMind has created a scholarships program to provide financial support, mentorship, and more to students from underrepresented groups seeking to study AI or a related field. To find out more, visit deepmind.com/scholarships.